For the longest time, we all thought quality was a pretty simple idea. Either a product worked or it didn't. But what if that whole way of thinking was just wrong? Today, we're diving into the game-changing ideas of Dr. Genichi Taguchi and his concept of robust design, a method that didn't just tweak our definition of quality, it completely blew it up and rebuilt it from scratch. Okay, to really get what Taguchi did, you have to see just how huge a leap in thinking this was. The old way, the traditional way, was all about one question: does it meet the spec? It was a simple yes or no, pass or fail. But Taguchi came along and asked something way bigger, way more profound. What is the loss to society? And just like that, the focus shifted from the factory floor to the entire world. So, here's how we're going to break it all down. We'll start with his wild new definition of quality, and then we'll see how he actually put a number on it. Then we'll get into the real heart of it all: robust design, before we walk through his 3-step plan to make it happen. And finally, we'll see why this wasn't just an improvement, it was a revolution. All right, first things first, let's tackle Taguchi's radical new definition of quality. This is the bedrock for everything else, and it forces us to think way beyond a simple checkbox. And there it is, right from the man himself. Quality is the loss imparted to society from the time a product is shipped. So what on earth does that mean? Well, it means quality isn't about passing an inspection. It's about the real, total impact a product has out in the world. We're talking about the cost of a warranty claim, sure, but also a customer's frustration when their new gadget is just a little bit glitchy. It's the whole ripple effect of imperfection. Now, saying quality is societal loss sounds great, right? It's a really powerful idea. But how do you actually measure that? How do you take this big philosophical concept and turn it into something an engineer can actually work with? Well, you guessed it, Taguchi had a plan for that too. Let's start with how things used to be done with what's called the goalpost approach. You can see it here. As long as your product lands between those two spec limits, it's considered 100% perfect. Zero loss. But the second it crosses that line, even by a hair, bam, it's a complete failure. So a part that just barely scrapes by is considered just as good as a part that's dead center perfect. Does that really feel right to you? And this is where Taguchi just completely flips the script. This is his quality loss function. See that smooth curve? It shows that loss isn't some cliff you fall off. It's a gentle slope that starts right at the center. The very instant a product isn't perfectly on target, some small loss occurs. And the farther away you get, the bigger and bigger that loss becomes. All of a sudden, close enough just doesn't cut it anymore. And believe it or not, he boiled this whole powerful idea down to one beautifully simple formula. It's a quadratic equation, L equals K times Y minus tau squared. Looks simple, right? But this little equation gave engineers a tool they'd never had before, and it changed everything. So let's quickly unpack what this all means. It's actually pretty straightforward. L is the loss, measured in actual money. Y is what you actually measure on your product. Could be its weight, its voltage, whatever. Tau, that's tau, is your perfect target. And K, well, K is the magic ingredient. It's a constant that connects the physical deviation to a real financial cost. It's the bridge between the engineering lab and the balance sheet. All right, so now we know what the problem is, societal loss, and we even have a way to put a number on it. The big question is, what do we do about it? And that brings us to the absolute cornerstone of Taguchi's entire philosophy, robust design. This isn't about fixing mistakes, it's about designing things so they can't fail in the first place. So what is robust design? Well, at its core, it's an approach to engineering that makes products and processes basically immune to what Taguchi called noise. And noise is just his catch-all term for all the messy, unpredictable, uncontrollable stuff that happens in the real world. And this right here is the genius of it. The old way was to try and control everything: the temperature, the materials, the operator, which is crazy expensive and honestly impossible. Taguchi said, forget that. Instead, let's create a design that's so fundamentally strong, so robust, that it just doesn't care about all that noise. You don't try to stop the storm, you just build a stronger house. Taguchi actually broke this noise down into 3 main types. You've got external noise, think about a car needing to work in the freezing Arctic and the scorching desert. Then there's deterioration noise, that's just good old-fashioned wear and tear over a product's life. And finally, internal noise, the tiny little differences you get from one product to the next right off the assembly line. A truly robust design has to stand up to all 3. Okay, so this all sounds great in theory, but how do you actually do it? How do you build one of these robust designs? Well, Taguchi laid out a super clear three-stage roadmap. This is how you put the philosophy into practice. It all starts with system design. This is the big picture, conceptual phase. But stage two, parameter design, this is where the real genius is. This is where you test and tweak all the design settings to find that magic combination that makes the product toughest against noise. And here's the kicker. You do it with cheap, standard parts. Only if that fails, as a last resort, do you move to tolerance design, which means spending more money on high-precision components. For Taguchi, winning in stage two was the whole game. So when you step back and look at everything we've just talked about, you realize this isn't just a small improvement. It's a total paradigm shift. It's about fundamentally changing from a reactive mindset to a proactive one. This table just lays it out perfectly. The old way, it's all about inspection, staying in bounds, and fixing things when they break. Cost is like a brick wall you try not to hit. The Taguchi approach, it's about designing for performance, aiming for perfection, and creating products that are immune to failure from the start. Cost isn't a wall, it's a hill you're always trying to slide down. And really, if you remember one thing, let it be this. You can't inspect quality into a product. It's not something you add at the end of the line. True quality, the kind Taguchi talked about, has to be designed in right from day one, right from the very first sketch. So I'll leave you with this to think about. The next time your phone is just a little bit laggy, or a tool feels just slightly off balance, the next time something is just good enough, ask yourself, how much hidden societal loss am I looking at right now? How much better could this be if it had been truly robust by design?